Now in this video we're gonna learn about sulphonation or desulphonation of benzene. So we have a benzene over here. When we react it with concentrated H2SO4 with heat or with oleum, then it forms benzene sulfonic acid. Now when benzene sulfonic acid is put under dilute H2SO4 or HCl at 150 degrees Celsius, so there is a desulphonation of benzene. We again get the benzene over here. So let's look deep into its mechanism. We have H2SO4 which is concentrated over here. So we have a lot of amount of H plus over here. So the the oxygen gonna attack over here with H plus and it form then H2O plus. Now here water molecule gonna leave over here and it form SO2H plus. Now here this oxygen will trying to resonate over here, or H plus will move from here. So we are getting negative side and there are a lot of H plus, so it easily can remove from here and it forms H plus and SO3. Now this SO3, then it got sulfur trioxide. Now when we react the reacting species is sulfur trioxide. So if we have benzene, when we try to put it under EAS condition, we know EAS condition we need to provide the higher temperature. So when this bond breaks, we get a positive charge over here, the negative charge gonna attack sulfur over here. So here it is hydrogen, then it is a positive charge and SO3 minus. Now we have a lot of H2SO4 here, so this SO3 taken the hydrogen from them, so it is HSO3 and H over here. Now we have an HSO4 minus, we are gonna take hydrogen from here and it got a negative charge and it formed benzene. So it is again benzene sulfonic acid we are forming here. Now when benzene sulfonic acid we are gonna react under dilute H2SO4 or HCl at 150 degrees Celsius. So when it is dilute H2SO4, so it gonna again there is a negative charge and there is a positive charge, so it gonna attack over here and it forms hydrogen here. Now when if this reaction going to proceed over here and the temperature we are providing is 150 degrees Celsius, so this SO3 is a very good leaving group. So that group gonna leave from here and we are getting over here the benzene and SO2 and H plus. Now if we look at this reaction, here we had H2SO4, that's why the reaction is going further, but the intermediate is same. Okay, intermediate is same, so we know the reaction conditions are different. Here we are using concentrated H2SO4. When we are using dilute H2SO4, this reaction gonna takes place. So we're gonna look over about now the preparation of picric acid. So picric acid, when we have the phenol with concentrated HNO3 and gonna form this nitrobenzene, this compound gonna form, and when this compound gonna form we will also get parabenzene quinoine. So this is the picric acid. Now when the phenol under dilute H2SO4 gonna form SO3M, and this is also minus M group, and here also it is a minus M group. When it is put under mixed acid, so it again form concentrated this picric acid. So there are two methods to form picric acid. So method 2 is better. In method 1, the oxidizing agent will oxidize highly activating ring phenol. In method 2 is better. Here the formation of picric acid is better by second method, because in method 1 oxidizing agent will oxidize highly. So it will highly oxidize the ring, so it may form this parabenzene quinone also. So it is a very highly oxidizing agent. So oxidation accomplished by nitration in method 1 due to sulfonation, electron density in the ring decreases. So oxidation accomplished by nitration in method 1 due to sulfonation, electron density in the ring decreases and chances of oxidation on the ring increases. So here the electron density on the ring decreases and chances of oxygen, this oxidation of this reaction also increases. This benzene ring. So oxidation of benzene increases, so it also gonna form parabenzene quinone. So here if we see the next compound, here the SO3H is a minus M group, which is reducing the electron density over. So when we use mixed acid, it gonna form the picric acid. Now how it helps in conversion? When we have toluene, when we use concentrated H2SO4, we know we can add HSO4 group and we can remove also. So it can very helpful in conversion from one compound to another compound. If we use this compound and we form it halogenation, so it may form ortho para substituted both. So what we do when we react it with concentrated H2SO4, we get that para substituted product. When this para substituted product we form the halogenation, it gets ortho portion from here. Because it is minus M, it is meta directing, it is the ortho directing. So surely chlorine gonna attack here. Now we treated it with dilute H2SO4 and gonna form desulphonation and we get now ortho substituted toluene. So it is very helpful while converting without having a multiple substituted compound.